So it says from 1940 to 1980, the average size, so F represents the average size of the U.S. farm in acres. This is our function that we're using now. So if it's not one of our original compounding formulas, the formula will be provided for you, okay? It'll be embedded in the question. There is a question like this on the test where we give you a different function that we want you to work with. Okay, so just realize this has two different variables. There's only two. F, which is the size of the farm, and then T, which is years since 1940. Now, yes, so that's important. So it says, what was the average farm size in 1950? How do you think what are we gonna do?
Subtract the current year with the year after.
Right, so 1950, if we started at 1940, how many years passed between 1940 and 1950? 10. So that means I'm going to use T equals 10 because 1950 minus 1940, that's a difference of 10 years. So all we have to do to find the farm size is substitute that into the function. So we have 174 e to the power of 0.022 times 10. So let's type that in. It doesn't tell us where to round, so we're just going to round to the 10th place. But again, on the test, it's very clear. It tells you where to round. So we're going to go to the 10th place. So how many acres was the average farm size in 1950? So I got 216.8 acres. And just so you also know, this first number here, this 174, that represents, because if you think about our compounding interest, we always start with P, which is the start. So this is 174 was my starting size in 1940. So you can always identify the start from the equation. All right, so now question B says, when was, so now I have to find T because it's asking me to find when. When was the average farm size 400 acres? So that means that F is 400. So I have 400 equals 174 E 0.022 T. Okay, so this is kind of that little skill check yesterday. The solving part didn't go as well as I thought it was going to go. So let's talk about it. What are we going to do first?
Put in natural log.
Nope. Don't put in natural log.
By 174.
You have to divide the 174 first. You have to get the E by itself. So you're going to have 400 over 174 equals E to the 0.022 T. Now we can put in our natural log. That's just going to cancel out E. Natural log and E are opposites, just like adding and subtracting, multiplying, dividing, square and the square root, they cancel each other. So what we have now is the natural log of this fraction equals 0.022 times T. And now what would be my last step? Divide by that interest rate. That 0.022, I don't know if you all kind of made the connection, that's your rate. So it's a 2.2% increase. Okay. So go ahead and type this in your calculators. And you can always type in the natural log of 400 over 174, hit enter, and then divide the 0.022. Because I feel like putting in a fraction for some people is a little tricky. So I'm going to actually round this because we're talking about a year. So let's round this to a whole number. So 38. So T equals 38, but we're not done yet though, because it's asking us for the year. So the year wasn't 38. When was the year? How do we figure out the year? Add the 38 to what? When did we start? 1940. So 1940 plus 38. So that means that in the year 1978, the average size of the farm was 400 acres. All right, any questions? All right, so that's a possible question. Now let's talk about number 8. That's another possible question. So we got the rate at which a liquid vitamin breaks down in the average human body can be modeled by this. So this is my function now. Y, it tells us, is the milliliters of the original dose. Where X remains Y is the milliliters of the original dose that remains after X minutes. So Y wouldn't be the start, it would be the what? The ending, the final amount. So after time. So that means that Y is kind of your ending milliliters. And generally, in most formulas, Y does represent the ending milliliters. The key thing, did I do something? Yeah. Okay, so the key thing here is that X is in what? It's not in years. It's in minutes. So X is in minutes. So we want to know how long will it take for an original dose of 15 milliliters to be reduced to 5. So D is your original dose. So we're trying to find X. All right, so we know that the original dose was 15. So 15 milliliters. And we want to know how long did it take, how many minutes for it to reduce down to 5. So that's the only two numbers we know. So we have 5 equals 15, and then it's 0.95 to the power of X. Okay, what are we gonna do? You always isolate the base. And when I say the base, I'm talking about the base of my exponent. That would be this. Thought that was a highlighter. This is the base. So you cannot put in a log or a natural log until you get rid of the 15. 15 is being multiplied, so we're gonna divide it. So that would be 1/3. Or you can even leave it as a fraction, it's 5 over 15, but I'm gonna write it as 1/3 equals 0.95 to the power of x. Okay, so we don't have a, again, we don't have a log with a base 0.95. Some people have fancy calculators that they can change the base in, like Justice. But most of us have just a regular calculator, and we have to do a common log or a natural log with a base 0.95. So it doesn't matter which one we use. Which one do you want to use? Let's use natural log. So if I put in the natural log, again, the power property tells us, because I can't solve for x as long as it's flying in the sky. X needs to come down. How do I get the x to come down? I put in a natural log. So what I have is the natural log of 1/3 equals x, which is now on the ground, times the natural log of 0.95. So to solve this, you simply need to divide. Let's go ahead and type it in our calculators. So I got that it's going to take 21.4 minutes. Don't forget your unit for this one because we're not talking about years. We're talking about minutes. So 21.4 minutes. So that's pretty fast that your body metabolized this particular vitamin for it to be absorbed in your body in only 20 minutes. About 21 minutes. All right, last question. And this one should fly by because it's just a simple plug and chug. All right, so we won the lottery, y'all. We got $1 million. We gonna save it for the future though. So we got 2 different plans. We're not gonna spend our money for 5 years. Okay. So we won $1 million. So let me go ahead and write this out. But we're not gonna go out and just start spending our money because we're responsible. We're going to wait 5 years. We're going to try to get some interest so we can have more money. So option A, the bank is going to give you 4% and it's going to compound it every month. So for this one, R is 0.04 and N is 12. So let's go ahead and see how much money we are going to get if we invested this $1 million. 1, 2, 3, 4, 5, 6. Okay, 1 plus 0.04 over 12 to the power of 12 times 5. It's a lot of zeros. 1, 2, 3, 1, 2, 3. Okay, so we would actually get an extra $220,000, y'all. That's a pretty good deal. So we didn't spend our money and we went with this first bank. We would have $1,220,997. I'm gonna round that to a whole dollar because if we millionaires, we not worried about change. We millionaires. Okay. You still gonna count change if you're a millionaire? Oh wow. All right. Option B says you can get a 8% rate and they're gonna compound it every 2 months. So let's talk about that because we haven't had that compound every 2 months. So for this one, my rate is 0.08. if I compound every 2 months, how many times will I compound in 1 year? 6. All right, let's see what we got this time. Well, that one we get a lot more money. It might be to our advantage to just let them hold it and get all its interest. For the second option, I would have $1,487,887. So, which plan would you recommend, A or B? B. And obviously, the reason why is because you would earn more interest. Oops, hit the wrong.